Hey, my name is Ben Teese. I work for Shine Solutions, and in this presentation I'm going to talk a little bit about RecRouter v4, specifically how it's different from RecRouter v2/3, and also how it helped me quite easily solve a particular scenario using authentication with Firebase. In a nutshell, RecRouter v4 is all about introducing real components and properties to the routing experience with React. I'll get a little bit more into this in a second, but despite outward appearances, RecRouter v2/3 isn't really very Reacty, so to speak. What looks like components is really just configuration, whereas in RecRouter v4 they are actual components. They get rendered and are therefore quite predictable in the way that they behave. Another thing that RecRouter v4 does differently is it kind of eschews the use of custom hooks for intercepting, for example, entering routes and so on, in favor of just using regular React component lifecycle methods like component did mount and so on. And again, this makes it much easier to reason about the way in which your routes and components are going to behave. And I guess the end result of all this is, in my experience, is that with RecRouter v4, sometimes you might write a little bit more code, but you get a lot more flexibility to meet your particular use case. You don't have to worry about as much about whether the React Router v2/3 API is going to meet your particular use cases. You don't have to hassle the React Router guys so much to make changes to meet your use case. It also just makes your code much easier to understand and reason about. And to be perfectly honest, it's probably going to make you a better React programmer as well. That said, if you are heavily committed to React Router v2/3, they are going to be merging bug fixes for a while. They're not completely abandoning that code base at all, because I think they understand that there's a lot of people out there already using it. Alright, so let's start with a simple example. I have my own personal projects that use RecRouter v4, but we haven't really got time to have me explain the whole context of them to you here, so I'm just going to use a good old to-do app to explain some concepts of RecRouter v4. This is going to be a route-driven application, so I'll just take it for a little spin now. And it also has a login page, so we're going to start on that login route, log in to the application. That will take us to a to-dos route. And we can just enter new to-do items in our list easily enough, and then we can also click through to a to-do item which has got its own route. You see the route up there in the address bar. It's got a long and convoluted ID. That's really just a Firebase ID, so don't worry too much about those. Basically, we're just looking at the route for a single to-do here. And if we click on the link up here, it'll take us back to our list of to-dos, and we can also then log back out of our application. So that's the app in action, and just to summarize, here are the routes we've got in play here. /login for logging in, then /todos for looking at a list of to-dos, and then finally /todos/ID for looking at the details of a particular ID. So how would we implement these sort of routes with v2 for starters, just for comparison's sake? Well, with RecRouter v2, you would initially bring in the router, the route, and the browser history. You then kind of wire them together here in the router component, and then you define routes inside the router component. And you can even do some cool stuff, kind of nest them a little bit and so on, which is kind of nice. That said, these routes, they're not actually real good React components. They actually just describe a configuration, and it's quite static. So if you, for example, try to re-render this router and feed new props into it, it will just kind of complain, to be honest. It's not designed to be rendered over and over again. And the routes really, they're just equivalent to a static JSON configuration. They're not very smart. So let's have a look at how we'd implement something like this with v4. In v4 we have a browser router that we can bring in from the React Router module, and it actually now has a bunch of different sorts of routers. Like there's a native router, a hash router, an in-memory router, a server-side router, or a router that you can use on the server side, and they're all designed to work in those different sort of contexts. But they also have a route component in common. And we're going to use that now. So we're going to declare our browser router here, and then we're just going to declare some routes inside of it. We'll start with login, and then to-dos, and then /to-dos ID. And one big thing worth noting here is that with RecRouter v4 routes, pretty much several routes can match at the same time. And if you don't want that to happen, you have to be quite specific about it. So in this case, if we tried to go to /to-dos/ID, both the /to-dos route and the /to-dos/ID route would match, unless we put this special qualifier in here to say, no, we only want /to-dos to match if it's exact. This seems kind of weird and a little bit annoying for a simple application like this, but the ability to match in multiple places is really handy when you're doing things like sidebars and stuff like that. That said, it's a common use case that you want to not worry about many things matching at once. So to deal with that, the RecRouter guys have provided this switch component, which you can actually insert in place like this. And all routes inside a switch, pretty much the first one to match will be matched, and then there won't be any subsequent matches. So in this case, what we're going to do is we're going to match /to-dos/ID first. If that doesn't match, then we'll give to-dos an opportunity to match. So we actually had to switch around /to-dos with /to-dos ID, but we did get to remove the exact property. But essentially what's on this screen is the same as what you saw in the previous screen. But I'm going to use the exact form for now, just because it's a little bit more terse for this example. Now, a common use case with routers is to want to share a little bit of markup between sub-routes or a particular part of your application. In the first instance, my app isn't doing that, but let's just say that /to-dos and /to-dos/ID, say that we wanted to put the text to-dos at the top of each one, and you can sort of see this here on the left and the right in these screenshots. How would we implement that with RecRouter v4? What we would actually do is RecRouter v4 routes, you can actually also provide a property called render, and instead of just rendering a component that you nominate, you can actually provide a function that will be rendered dynamically, which is pretty cool. And what we're going to do in this case is we're going to make it that the render function turns a div that's got a to-dos item at the top, and then the routes are actually defined inside of it. So we're going to match /to-dos directly here, and then /to-dos ID afterwards. But both of the /to-dos routes will share some common content. That said, you might be getting a little bit alarmed just at the sheer number of times I've written to-dos there, or /to-dos. So it's worth noting that components, both components that you provide as properties to route or render functions that you provide, have parameters provided to them about the route that's been matched. And one of the properties in the object that you're given is a path, and I'm just going to destructure it straight out of this argument. And what I can then do is use that path to dynamically assemble subroutes. So this saves me having to write /to-dos over and over again. And this is kind of the way, or one way, in which you can do nested routes with RecRouter v4. So a little bit more work, but it's a lot more explicit about what's going on. You've got a lot more flexibility and degrees of freedom as to how you structure things. Next thing I just want to quickly look at is links in RecRouter v4. Here's an example of a link in action. The sort of title link up the top, which takes me back when I click it to the /to-dos route. I'll give it another go there. How do we implement something like that with RecRouter v2 versus v4? And I guess the good news is that at least for simple scenarios, with v2, we would have just brought in a link from the RecRouter module and then just said where we want it to go to. And in v4, it's pretty much exactly the same, at least for this quite simple use case. So no real change there. Finally, perhaps the biggest, most significant scenario that you'll need to get your head around with RecRouter v4 is redirects. And let's just be clear about what we mean by redirect. So I just logged out and a redirect happened. It redirected from /to-dos to /login, and similarly when I log in, it's going to redirect from login back to to-dos. So there's redirects happening here all the time. Here's another redirect back to the login page when we do a logout. So how do we implement that with RecRouter v2 versus v4? In v2 we would have used the with router higher order component. we would have wrapped our component with router, and that would mean that, say for example, we had a logout component and it was just a simple link that we wanted to click to log out. The implementation of the event handler might do some back-end stuff for logging out, and then it would explicitly use properties or router properties that have been given to it by the hire component to say that you want to go to the /login route. In v4, it's kind of a different approach. We have a redirect component provided to us by React Router v4, and technically speaking there was one in earlier versions of React Router, but it was more of a declarative thing that would just allow you to statically define a to and a from destination, whereas this component is actually quite dynamic in that it's designed to be rendered. So what we're going to do in our render method for the logout component, we're actually going to look at some state that's been set, and we're going to say, well, if the state indicates that we should redirect, then we're going to render a redirect, so to speak, to the login page. Otherwise, we will just, if that flag is set to, should redirect is set to false, we're just going to display a regular logout link. And then we control this redirect process by using setState in the logout method. So this is a little bit unusual, but I encourage you to keep an open mind, at least for the remainder of this presentation, because what I'm going to do now is show you how the redirect component in particular makes things like authentication quite straightforward, or at least for me that it did. I'm not sure if you've ever used Firebase. It's originally started as kind of a real-time database, and it's kind of handy for very quickly getting a back-end up and running. And it's also got some great authentication functions built into it. I mean, just in a nutshell, the way in which you log in with Firebase is there is a Firebase module that you can use, and to log in, you just call this sign in with email and password method. Similarly to log out, there's a sign out method that you call. So you might be wondering, well, Ben, you've just called these methods, but how do you know whether sign in succeeded or whether sign out succeeded? And these methods do actually, in theory, return promises, but the Firebase people kind of discourage you from using those promises because sign in and sign out aren't the only two scenarios where your login state can change. So for example, your session might have timed out, for example, or the app might have just been reloaded, and at least for a small period of time, it might be unclear as to whether you are logged in or logged out or not. Firebase might need to, or this Firebase library might need to figure that out and then, sort of call you after a small period of time. So the way in which the Firebase docs encourage you to do authentication is to use this method called onAuthStateChanged, and it's sort of the one place in your application where you will register for a callback to occur, and that callback will get called with a user when the authentication state of the application changes. So if the callback is called with an actual user object, it means that you are logged in. And that may be because you've just logged in explicitly, or because the app reloaded and then Firebase on the client side figured out that yes, you had been logged in before. Similarly, if you were to log out or explicitly, or to be, if your session was to time out or something like that, then this callback will be called with null. So what we're going to do is, in our component did mount at a very high level within our application, we're going to register to receive notifications about this event, and we're going to set some state ourselves. We're going to set the user and to keep track. And the good thing is, what we're going to do is see how for 4 different scenarios, React Router v4 makes it very easy to flick our app into the correct state depending upon the state of the user, or how the user state's been set. And these 4 scenarios are the obvious ones, like protecting a private route. So we want to stop people going to a route that they're not allowed to go to if they're not logged in. And then we'll look at the obvious scenario of login, and then the logout scenario, and then finally the scenario of application reload. And I guess what I found is that in my limited experience using React Router v2/3, getting all of these scenarios right with an event-based authentication system like Firebase, like that provided by Firebase, can be a real pain, whereas it's very easy with React Router v4. So let's look at the first scenario, which is protecting a private route. And just to be clear about what we're talking about here, I'm just going to sort of show you what I mean. If I go to /login and then try to go to to-dos, it's going to redirect me Basically, I want it to redirect me back to login. How do we implement something like that with RackRouter v4? Well, what we're going to do is when we set up the routes down here, we're going to destruct the user out of the state, and this is the user that's being set in our component did mount based upon the Firebase callback. And when we declare the route, we're going to provide a render method, and it actually checks whether the user is set. And if they are set, then it's all good, they're logged in, so it will display the user's component, and we'll actually pass the user through to the component because the component will need to know about the user in order to get that particular user's to-do items. If there is no user defined, we're just going to immediately redirect to the login page. So having this, this alone is enough to basically protect the /todos route from being accessed if the user is not logged in. But the cool part is that this actually covers us for the logout scenario as well. Because if you are on the to-dos route, and we'll kind of work through this sort of dynamically as we watch this demo in case. If we're in the /todos route and we choose to log out, then our user is set to null and our component re-renders, and if we consider that code back on the previous slide, it'll match to /todos, but then it'll check if the user is defined, it'll realize the user isn't defined, and it will redirect to login. So essentially we've just got 2 for 1. We implemented a private route protection and got a simple logout going at the same time. Let's look at the next scenario, which is logging in, and just to make sure everyone knows what we're talking about, I'll do a login. So we're on /login, we're going to enter our username and password, and we will log in and go to the /todos route. So how do we implement this with RackRouter v4? Again, we can take a similar kind of approach where we can make it that the login route checks if the user exists, and if the user does exist, all that it needs to do is redirect to to-dos. Otherwise, it will show the login route again. And this is enough for us to implement login on its own. If we walk through this scenario, they're on the /login route, they enter their username and password, it's sent to Firebase, the Firebase event gets triggered, the user is set to some object, and the component hierarchy is rendered again, and the route kind of gets re-rendered again, but this time it will redirect to the to-dos page, which is kind of cool. And another side effect of this is that it kind of gives us this additional sort of sleeper scenario of protecting a private route. And this is where often, not always, but often, if someone's logged in, it doesn't make sense to try and show them or for them to go to the login route. And that's exactly, our code will protect that scenario from happening. So if I just run this demo, I'm on to-dos, and if I try and go to login, it'll go, no, you're already logged in. I'm not going to show you the login page. I'm just going to redirect you back to the to-dos page. So in implementing logout just then, we also managed to get this protection of a route that's really only supposed to be shown to logged out users. Our final scenario relates to reloading the app. So, and this can be a really tricky one I found with event-based auth systems. But fortunately, it's a total no-brainer with RackRouter v4. What we're going to do is we're going to bring in just the common React spinner library, and in our render method for the app, we're just going to check if the user is undefined. So the user is something on the state, but if the callback's never been called, if the Firebase callback's never been called, then the user will not be null and it will not be an object. It'll just be undefined. And so we can use that value to indicate that the state is that we just don't know yet whether the user has been logged in or not. The callback just hasn't been called one way or the other. So if the user is defined, we're just going to display a spinner in place. If not, we're going to start rendering our routes. But we don't really have to bother about rendering any of them until we've at least got an idea as to whether the user is logged in or not. So we can just demo this in action. I've got the app here, and I'm just going to click the reload link, and you'll see that the spinner's displaying there. We'll just run through it again. Now you see the hamburger in the top right briefly doesn't appear for a bit. I haven't actually shown you the code for rendering that hamburger, but when the hamburger's not there, that means that the app doesn't know whether they're logged in or out or not, because it doesn't want to show a logout link if they're not logged in. So when we reload the app, the spinner's there, the hamburger's not there. We'll try again. Spinner's there, hamburger's not there, then hamburger appears, spinner stays there actually because from that point onwards it's loading data from the back end. So there, very quickly and easily, and in a really easy to reason about way, we were able to deal with this scenario where the whole app is reloaded, and for a second there, it doesn't know whether the user is logged in or not, which is really cool. Finally, we can refactor some of this duplicated code that we had here for protecting routes. So I've only really been using /todos as my sort of case study on how to protect a route, but obviously there's other routes we want to protect as well. For example, /todos/ID. But fortunately, it's very easy to reuse this logic for checking the user and to kind of put it in a meta component, so to speak, that wraps other components. We're going to define that component as private route. We'll call it private route. And here we see it being used in two ways, and it's just like a regular route in that it can take a path and a component, but it also will take a user and it will use that user to determine whether it should actually show the desired route or whether it should redirect to the login page. And it can even take additional properties like exact and so on. So what does the code for this private route look like? It's a little bit intimidating if you're new to React, but I'll just briefly walk you through it. It's just a stateless functional component that takes another component as an argument and a user. It renders a route dynamically. That route has a render method that, as we saw before, checks for the presence of the user. If the user is defined, then it will render the component you provided to it and pass the user through. Otherwise, it will redirect to the login page. And that's pretty much a very simple component that we can use to create private or protected routes whenever we want to. That said, don't be too intimidated by it. I actually just stole that source code from the React Router v4 website, which is an excellent website that I highly recommend you check out. I'll show you the URL in a sec. So let's wrap up now. React Router v4 is all about real components and properties, which are much easier to reason about when it comes to complex or even frankly just non-trivial routing scenarios like authentication. The key to it though is that it's all about composition. We kind of already knew with React, composition is king. It's all about combining components and slicing and dicing them. And I think that React Router v4 gives us a really good API for combining components to meet our particular needs. And the end result is it might be a little bit more code, but it's a lot more flexibility, and I'm positive that you will end up a better React programmer just by dealing with the React Router v4 API. So if you want to learn more about it, I highly recommend the React Router website at reacttraining.com. The guys have provided a bunch of kind of recipes for different scenarios like sidebars and auth and animations. There's really interesting stuff in particular happening at the moment on the animation front. It's not so much on the website right now at the time I'm recording this, but I'm seeing some demos coming out for React Native animated transitions, sort of route driven, and it looks like they might give the regular React Native navigators a run for their money. Thanks very much. Bye-bye.